Drinking water sort of piqued my interest because I've done water research in the environment. So I sort of went into the background research there, and then our team sort of set our goal on how can we create a solution to solve the issue of microplastics in drinking water. There was a bacteria discovered in Asia. They found the bacteria was actually eating the plastics. So scientists, they isolated it and they decide, hey, what if we bioengineer this? So they took the gene from the bacteria and they placed it in algae. So the bioengineered algae was already existing before our team got to it. A lot of times wastewater treatment plants, they put all these resources into keeping the algae out of the wastewater. But we were like, hey, what if we put it in? Which, was an unconventional thought at the time. Essentially, we put this in a wastewater treatment process. You put it in there, you let the algae do its thing, you let it sit in the water for a bit, and it essentially excretes this enzyme to break down these plastics. When you think about plastic, they're called polymers too, right? They're chains of monomers, and they're chained together for these long strains. And essentially what the enzyme does is it cuts it. It's less of an issue once the polymers are released into its subset monomers. It creates less of an environmental concern when they're discharged into the environment. It's a big passion of mine. I think as a student continuing, I want to continue my research and I want to create an impact for our community, specifically Charlotte.